video, we are continuing with our convolutional neural network series. So in this video, I'm going to show you how you can classify, how you can use a convolutional neural network to classify images from TensorFlow dataset, right? So in this case, the first thing that I've done is I've imported this TensorFlow library. Import TensorFlow as TF from tensorflow.keras. So if you still remember, I said that keras is the API that runs on top of TensorFlow. It uses TensorFlow as the backend, right? So from tensorflow.keras, import datasets. We are going to import the dataset. That is the dataset that we are going to use. We are going to import the layers models, and then we are going to import matplotlib. So matplotlib is a mathematical library that we use to draw like graphs, right? So first thing that we are going to do is we are going to import these libraries. So in this case, I'm using Google Colab. So now we are going to map our training images and then train labels. Remember that when you feed our neural network, we have the training images and the training labels. And then we have the test images and then the test labels. So remember that we train our neural network on the training set. And then we then test our neural network using the test images. And then that is the images that our neural network hasn't seen. So in this case, it's goes to tensorflow.scify10.load data. So this is going to load the data from this is going to load the dataset from the keras dataset or TensorFlow dataset, right? And then we are going to map our classes. We are going to create a list of our classes. So the first class is airplane, automobile, bird, cat, deer, dog, frog, horse, sheep, and then truck. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 classes that we want to classify, right, from our images, right? So we then use matplotlib pot.figsize. We want a 10 by 10 matrix. So we want to loop inside this 10 by 10 matrix. We want to loop from I is equal to 0 up to range of 25, right? And then we want a subplot of 5 by 5. And then we are going to loop through the class names, right? So in this case, we have the frog, we have the truck, we have the deer, automobile. So it's doing it randomly, right? So once we have done this, the next thing that we are going to do is we are going to define our neural network, right? So we define our neural network in a sequence, right? We define our neural network in a sequence. So we are going to say that our neural network model is equals to models.sequential. So this means that we are initializing the sequential class from keras. That means that we are going to define our model in a sequence, right? So with the first layer that we are going to add into our neural network is model.add layers.convolutional 2D. Convolutional 2D. So if you have not yet watched my introduction to convolutional neural network video, make sure you watch that video so that you get a thorough understanding of how convolutional neural network works. So this case is that we want 32 kernels, or we want 32 filters. So here we say the number of filters, we want 32 filters. The filters, we want the size of the filters to be a 3 by 3 matrix. We then want the activation of our neural network to be the ReLU activation. The input shape of our image, we want a 32, a height of 32, width of 32, and then a depth of 3. Remember that, guys, images are 3D. So we have the RGB, we have the red, green, blue. So we define this by 3. This is the depth. And then, if you still remember, when creating our neural networks, we use what we call convolution, max pooling, convolution, max pooling, ReLU, convolution, max pooling, ReLU, convolution, max pooling, ReLU, convolution, max pooling, ReLU. You should remember that. Remember that phrase: convolution, max pooling, ReLU, convolution, max pooling, ReLU. That's the ReLU, that's the activation, right? So in this case, we have put 32 filters. We want a 33 by 3 kernel size, activation, ReLU, input shape, height of 32, width of 32, a depth of 3. We then use the max pooling 2D. With the next layer add is model.add layers max pooling 2D. So guys, max pooling, remember max pooling, If you have not watched my previous videos, watch my previous video on max pooling. You get a thorough understanding of what is max pooling. We then add another convolution layer, module.add layers, convolutional 2D, 164 filters with a 3x3. Want the filter size to be 3x3, we put a ReLU of activation ReLU. We then use max pooling with a metric size of 2x2. We then add another layer of convolution, 164 convolution, 64 filters. I want the filter size to be 3x3. The activation want it to be ReLU, right? Let's run it, right? And then this module.summary will show us the summary of our convolutional neural network. In this case, it shows us we have a convolutional 2D layer. We have a convolutional 2D layer. We have 32 convolutions. It has 896 parameters. We have max pooling 2D, 0 parameters. Convolutional 2D, 1, that's another one. We have 18,496 parameters, right? So let's go on. We then, after adding this, after convolution, we then flatten our output data, right? We flatten it in an array, right? In a single array, as you can see, flatten. We then add a fully connected layer. So I talked about this in my previous video. So guys, make sure if you have not watched my previous video, go and check that video. You get a thorough understanding of where this is coming from. Module.add layers.dense. We add 64 dense layers, right? So these are fully connected neural networks. And then after this, right, guys, we then add module.dense, want 10 layers, right? Module.dense, and then we add 10. Since we have 10 classes, right? And in this case, the activation will be a softmax, right? We'll use a softmax activation, right? Activation, it will be a softmax since it will squash the results into probabilities of each class. Let's say if the picture is a track, then we'll maybe get a 0.70 probability that it's a track, right? Activation, we use softmax. And then, okay, I made a typo. I'm sorry about that. Activation, we then use a softmax, right, guys? So the next thing that we are going to do is we then compile our module. We then compile our neural network. So there are parameters that we need to compile our module. The first parameter is an optimizer. So in this case, I'm using the Adam optimizer. So if you want a video on optimizers, guys, make sure you comment down below in the comments box so that I will do a video on optimizers. We then use our loss function. We get it from the tensorflow.keras.losses. We then use this sparse categorical cost entropy, right? The metrics, we use the accuracy metrics. We then fit our data set to the neural network. So we use the model.fit. We provide it with the train images, the train labels, epochs, right, guys? So the epochs is the number of iterations, iterations that we want our module to run, the number of propagation that our neural network to run. It's one epoch, it's one propagation, right? It's one forward propagation and one backward propagation. That's one epoch. So in this case, if there are 10 epochs, that means that we want 10 forward and backward propagation, right? So now we run the neural network, right? We run the neural network. We run this compile module. As you can see, it's now my neural network is now running. So I'm just going to pause the video a while, as it's going to take a while to train the neural network, and then I'll just come. Welcome back to the video. Now that our neural network training is complete, as you can see, we have an accuracy of 77% and a validation accuracy of 68%. That's not bad though for our neural network, but it can do better. It can do better. So for this video, I just wanted to show you how to create a neural network that can classify images. But in the next video, what we are going to be doing is we are going to be optimizing our neural network, right? As we can see here, we trained our neural network, and then after this, we then use the matplotlib to plot the graphs for the accuracy and then the validation accuracy. So as you still remember, guys, from my video that I made, that the accuracy shows us how well our neural network is doing on the training set, and then the validation accuracy shows us how well our neural network is doing on the validation data, right? If you still remember, if you have not watched that video, please go back and watch that video. So guys, thank you guys for watching, guys. Please do me a favor, hit the subscribe button, like the video, and make sure you share this video with your friends, guys. If you want to learn machine learning videos, I'll be dropping a machine learning video, deep learning video every week. Stay tuned, guys. Cheers.